Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share, and anywhere you see our video, help us to share it, and also subscribe. Subscribe if you have not subscribed before. We have over 220 videos on our platform. It means you can come to this place and learn any topic of your choice without any problem. They are very simple, they are for you. But before you leave the channel, make sure you subscribe, and if you need, just share among your friends. Anything you need on mathematics, physics, chemistry available. Now in this video I have simple pendulum for you, which is let me quickly, we have done video 1, video 2, which is a circular motion, simple harmonic motion. Now this time around I'm to work on simple pendulum. Now when we talk about simple pendulum, the motion of a simple pendulum is a typical example of a simple harmonic motion. Simple harmonic motion. All equation given in simple harmonic motion can be used also here. Now, for instance, given as, okay, pendulum is given as t equals to 2 pi root of t all over g, which I've done all this earlier. My peak length and peak of t is called periods, which I've told you is always in what? Period of the pendulum. Now, which is always in seconds, I've told you. Now, and also my t is the time. My t, okay. Oh, we are talking about length. Sorry, this is length. It means my length, which is my L, is the length of pendulum. Length of pendulum in meter, which is m, and the other one, which is called g. G is a acceleration due to gravity, which is always in meter per second squared, Now, when the pendulum, the period t and length, which is in meter, length, let me just, T1 length can be L1 of a particular pendulum can be compared with the period 2, which is known as and length 2 of the same or different pendulum. In the location. Okay, that is what I want you to know there. That that is very, very important. The length of a pendulum. The length of a pendulum is means distinguishing factor from other pendulum. Now, when we talk about pendulum, which is a very, very important thing that we need to understand. Now, if I have this equation, I have T equals to 2 pi root of L all over gravity. Now, square both sides. It will be T squared equals to 4 pi squared all over L all over G, which is this. Now, with this, I can continue by having which I can call it, call this one equation 1, call this one equation 2. Now, since I have my equation 1 and my equation 2, now, okay, from the first pendulum, which is equation 2, from the first pendulum equation 2 becomes T21 equals to 4 pi L1 all over G, which is from the first one, T21 all over L1. Even I don't need to put L1, which is, I can call it equation 3. Now, from this, I can rearrange by having I can rearrange by having 4 pi squared all over G equals to T squared 1 divided by L1. Now, which I rearrange it, which I have something good. From there, I can also continue by having which is, I call it equation 4. Now, from here, I can also continue by having 4 pi squared divided by G is a fixed constant for all pendulum. Of whatever length in a particular location. Now, for second, which is second pendulum, equation 2 become, this is my equation 2, which will become t squared 2 4 pi squared L2 divided by G. Now, which I can also rearrange or rearranging, which I have 4 pi squared divided by G equals to 4 squared 2 divided by L2. That is all. Now, when I equate, let me call this one equation. Okay, let me call it equation 5. Now, with this, if I have something like this, equate equation 4 with equation 5. It means I'll be having t squared 1 all over L1 equals to t2 squared divided by L2, which I can also say that t squared 1 all over 2 equals to 1 divided by what? L2, which I can also say that t21 divided by t2 equals to root of L1 divided by L2, which I can also say that, sorry, I have to mind here, t21 all over squared equals to root of L1 divided by root of L2. That is all we can say. Now, let me quickly talk about now, whatever the period and frequency of the simple pendulum that makes okay, let me quickly explain this example that can really help us on this part of this pendulum. Now, for instance, what is the pendulum? What is the period, frequency of a simple harmonic motion? Simple, I'm not talking about simple pendulum. Simple pendulum, sorry. Simple pendulum that makes 40 oscillation in 35 seconds. Now, this is a very simple question that you can be asked in any exam, which something related like this. Anytime you have something like this, just note that your period is equals to time of oscillation divided by what? Number of oscillation. Time of oscillation divided by number of oscillation. Let me quickly explain it. This is called time of oscillation divided by number of oscillation. Now, which I can say that also my frequency f is always equals to 1 all over period, which is number of oscillation divided by time of oscillation, which is n all over t. N over 2. It means inverse of time. We all know that my frequency is only equals to 1 all over period, which we all know that. We all know that our frequency is always equals to okay, that is unit of finding frequency. Now I have this question to solve. Don't forget that what is the period? What is the period and frequency? And frequency. It means I'm looking for period and I'm also looking for period frequency. My period will now be equals to what is we have 40 oscillation, which is it means 35 all over 40, which is I've explained that, which is to be 0.87 seconds. Now also my frequency, which is my frequency, it will be equals to number of oscillation divided by time of oscillation, which is 1 all over. I can also say that 40 divided by 35, which it will give me 1.14. Now, or frequency equals to 1 all over period, which I have 1 all over 0.7, which it will be 1.14. Now, anyhow you do it, that is how you feel like. Now, let me generate more examples on this part, which is to really help us to know this very well. Now, I have this question. A boy, time 30 oscillation of a certain pendulum tries and obtain 1 minute 10 seconds, 1 minute 12 seconds, 1 minute 7 seconds, respectively. The mean period of oscillation of the pendulum on question mark is, you don't know it. Now, when I have something like this, solution to this problem, the very simple one that you have to understand what the question is all about. The first thing you do is that we are talking about now I need to convert time, the period, which is my period, is always equals to n all over, t all over n, time of oscillation all over number of oscillation, which I have time of 3, the first time, the second time, and the third time. Now it means I will have period 1, period 2, period 3. Now, let me start from period 1. My period 1, which is my first time, we are talking about 30 oscillation. It means my n is equals to 30. Right? N is equals to 30. The first one will be T1, which is I'll be talking about 1 minute 10 seconds divided by 30, which I will convert this one to seconds. It will be 70 seconds divided by 30, which I will be talking about 2.33 seconds. Now my T2 which is period 2, will be, which is that time of second, which is, I have 1 minute, 12 seconds, divided by 30 period, which are 30 oscillation, which I will be having 72 all over 30, which with the help of my calculator, that it will be 2.4 seconds. Now, I'll move on to T3, which I'll be having 1 minute, 7 seconds, which it will be 67 all over 30. I'm just converting to seconds before 1 minute, 1 second, which is I have it will be 2.23 seconds. Now, these are the time I have. Now, I will now move on to the period now. We all know that my period is known as my T, which I'll be having. I want to look for the mean, or we call it average. Mean or average, it means I will add up T1 plus T2 plus T3. How many are they? 1, 2, 3, all over 3. Which we are saying that everything you have here, we have 2.33 plus 2.4 plus 2.23 divided by 3, which is, that is the average, which I'll be having 6.9 something. 6.96. That will be, it means my period will be equal to 6.93 divided by 30. I mean divided by 3 rather. Divided by 3. Now, which I can now press, which I'll be having 2.32 seconds. That is the time we are talking about. That is time we are talking about. Okay, my time. Okay, let me show one or more example before I go to the next one. I have this question also. Okay, of a simple pendulum of 0.25 seconds swing from its equilibrium position. This is position 1, the string end. Calculate its period. Calculate its period. Solution to this problem. Now, with what is on ground, let me quickly expatiate with my diagram. Before. Now, we all know what's okay. This is always done in the lab. Now, it will be of this, which I call it move on A. This is the origin, 0, and come back, call this place 1, come back to 2, 2 give back to 3, which is B, call it 3, and this is going to be 4. That is how it will be going and going and going and going. Now, from this, now if it takes 0.25 seconds for the ball now to string from 0 to A, it will then take 4 multiplied by, because 1, 2, 3, 4. 4 multiplied by is 0.25, which is Now, 2 seconds to undergo 1 oscillation. Now it means I will just continue by having, we all know that 1 to 2 to 3 to 4, that is just how it is. Or you have it in terms of, or 0, this is O to A to B to O to what? To B. Anyhow you want to do it. Now it means I'll be talking about what? My period equals to time of oscillation divided by the number of oscillations. My number of oscillation is 1, which is, my end is always 1, which is 1 time, and the time of oscillation is given, which is okay. It means I'm talking about 4 multiplied by, it means my period will be equals to 4 multiplied by 0.25 divided by 1, which is, I'll be having it in seconds. My final answer will now be okay, that'll be 1 all over 1, because of this is already 1 over 4. 1 all over 4 divided by 1, which is I'll have 1 seconds. That is my final answer. Okay. Okay, that is 1 second. I think with this, you are good to go on the simple pendulum. If you have any problem, contact us. No problem. I will to be surely attend to. Once again, you are on with Further Solutions Academy, and don't forget that I have told you earlier that this is the whole thing, that we have T21 all over T2 squared equals to L1 all over L2. Please don't forget this. You can look at them and check more examples on simple pendulum. Don't forget you are on with Further Solutions Academy. Encourage us more to share anywhere you see our video, and also if you have not subscribed before, make sure you press on your subscribe button. Just subscribe for us, for you to get direct update. We have over 200 videos on our platform, and if you want to comment or you want to drop any message, you can reach us on this line 834495997. With this, you can call us, you can WhatsApp us, and Telegram is allowed. Once again, thanks for watching.